Okay, hopefully you've read through the introduction there that was written and typed into Canvas about section 9.3. We are working with dependent samples instead of independent samples, and I opted to do this section um, from chapter 9 because it's different than anything we've done so far. KBOR has a list of things that we have to cover this semester. We're going to do our best to meet those goals, but working with dependent samples, I think, was one that we shouldn't leave out. In our hypothesis test, now when we are working with dependent samples, is instead of saying that this mean is equal to that mean or that this mean is greater than that mean, we want to find the mean of all the differences of our data values from our two samples. And our hypothesis for the null is always going to be that that mean of that distance, that's a capital D, by the way, is equal to 0. And then for our alternative, as usual, we'll either have a left-tailed test, a right-tailed test, or a two-tailed test according to what's being discussed in the problem. So we'll pick one of those symbols to put in between. On your formula card, and I'm glad that I got all of those photocopies out before we left for spring break. If for some reason you were not in class on a day that something was handed out and you need it, let me know and I'll try to get you an image of those formulas. But when we talk about capital D, it's the difference between two data values where x1 is a value from population 1 and x2 is a value from population 2. Once we've taken x1 minus x2 for each pair, paired up order or pair of data values, then we'll find the mean of all those differences. Remember, you find the mean by adding up all of the numbers you have and dividing by n. Okay, n is the number of pairs of data that you have. Because these samples are dependent, it is a one-to-one ratio. So if there are 50 in one sample, there's 50 in the other sample, and so on down the road. Where in the past sections, it could be a different number. I could sample 20 items from this group and 30 items from that group. Now the standard deviation of these differences, and this just uses the formulas that we learned from back in chapter 3. All of these formulas are there, only now we're tweaking them. Instead of calling them x's and xf's, we're calling them d's. But the number of pairs times the sum of the d squareds, we're going to subtract the sum of the d's, that quantity squared, and divide it by n times n minus 1. Then our error, okay, our sampling error of the sample means, if I have the terminology right, remember, was our standard deviation over the square root of n, over the square root of our sample size. Our test statistic, just like it always is, our z-score, our t-score, whatever we happen to be using, is our observed value minus our accepted value over the standard deviation, the appropriate one for that situation. Our degrees of freedom in this section are still n minus 1. And again, when we had samples that had different sizes, we picked the smaller of the two. But again, here we have paired data, a 1-to-1 ratio there. So n is n for both situations. So in the next video, we'll do one example of this.